So today we're going to answer why abdominal obesity is associated with increased levels of circulating IL-6 compared to lower body obesity, which is associated with lower levels of IL-6. So in this slide here we have our massive interest, which is plasma IL-6, which we are saying that in the abdominal obese individuals it's higher than those who have lower body obesity. So when looking at outflow for plasma IL-6, we can see that in the peripheral tissue is uptaken, and as well as plasma IL-6 removal, which is done through enzyme activity. But however, for this case, we're not going to worry about outflow as it was not discussed in class. So now looking at our inflow for plasma IL-6, we have adipose tissue IL-6, which is coming from hypertrophied adipose tissues. Macrophages and cytokines are released when hypertrophied adipose tissues occur, which release adipose tissue IL-6. Hypertrophied tissues obviously come from an increased amount of storage of plasma-free fatty acid, which in this case is our obese individual, which will lead to increases in storage of plasma-free fatty acid, which leads to hypertrophied adipose tissues, which then in a cascade of things increases plasma IL-6. We then found a study by Matsuzawa and friends, which noticed that there is a difference in fats between visceral and subcutaneous. Visceral in this case being located in the abdomen, and in the other case subcutaneous being located in the peripheral. So our hypothesis for this situation is that visceral fat secretes more IL-6 once hypertrophied compared to subcutaneous. To fit this hypothesis into our model, we are stating that visceral fat secretes more IL-6 than subcutaneous fat, which therefore leads to an increase in adipose tissue IL-6, which therefore increases our plasma IL-6.
So we found a study that looked at 10 obese subjects about to go to surgery. They obtained omental fat or visceral fat and subcutaneous tissue as well. They placed the tissue in a medium for incubation and they measured IL-6. There was no difference in the tissue size between the two fats, or the hypertrophy based on the size. So the results showed that omental adipose tissue secretes more IL-6 than subcutaneous fat does in obese humans. It also shows that the cells in omental adipocytes secrete more IL-6 than subcutaneous fats in obese humans. Another result shows that there's a significant difference between the IL-6 release between subcutaneous fat and omental fat between day 1 and day 7. Therefore, there's a chronic elevation of IL-6. So these results confirm my hypothesis that visceral or omental fat does secrete more IL-6 than subcutaneous fat does. So that since there's more secretion of IL-6, there is more IL-6 in the adipose tissue, which leads to more IL-6 in the plasma.
So what's the rationale that visceral or mental fat does secrete more IL-6 than subcutaneous fat? Well, these authors suggested that cortisol may inhibit and therefore modulate IL-6 production. They also said that cortisol turnover may be exaggerated in visceral obesity relative to subcutaneous obesity. How would this look into our model? Well, looking at cortisol down here in the bottom, we would say that cortisol turnover would represent the outflow for cortisol, and that cortisol production or release would represent the inflow for cortisol. So, if cortisol turnover is exaggerated in visceral obesity, that means that we have more outflow for cortisol in visceral obesity, and therefore less cortisol in our blood, meaning less inhibition of the production of IL-6 in our adipose tissue, ultimately leading to more adipose tissue IL-6 and therefore more plasma IL-6. What's the proof of this? Well, we found this other study here by Marin and Darren and friends that looked at visceral and omental obesity here on the x-axis, represented by the waist-to-hip ratio, as well as the cortisol in the blood, and they found that with greater levels of visceral and mental obesity, there's less cortisol in the blood. Therefore, going back to our model, we can see that with visceral obesity, there's more cortisol turnover, as suggested by the previous authors as well, leading to decreased cortisol as the outflow is increasing for blood cortisol. Therefore, to put this back in our overall model, we are saying that with abdominal obesity, which indicates visceral or mental obesity, there's more cortisol turnover, which will lead to less cortisol in our blood, which will lead to less inhibition of the production of IL-6 in our adipose tissue, which ultimately, as previously stated, leads to increased adipose tissue IL-6 and therefore increased plasma IL-6. So to conclude back to our original problem, we are saying that with visceral obesity, as seen in the person who stores more fat in the abdomen, there's increased visceral fat, there's also increased cortisol turnover, which will decrease cortisol, decrease the inhibition of IL-6 production, increase the inflow for plasma IL-6, and therefore increase plasma IL-6, which, as stated in the original problem, leads to more poor health outcomes.